In this video, we're gonna talk about misleading graphs, how what kind of mistakes to look for, and how to spot those mistakes. And I just want to say right away that some mistakes are intentional and some are not intentional. So here's a first mistake or misleading graph, um, which results from breaks in a number line. What do I mean? So if you compare the graph on the left and the graph on the right, you see that um, the difference is huge in the um, red bar versus the blue bar, even though it represents the same information. So both graphs, they're showing the personal income per capita in California and Nevada. So if you look at the numbers for California are 32,996, and for Nevada is 30,180. So there is a difference, but the difference is not that huge. Um, in especially if you convert it into percentage change. But look at this graph. What a huge difference. And the reason is because on the in the graph on the right, they don't show the entire height of the bars, but they start at 30. So they cut off um, a piece of a number line from 0 to 30,000. And that's why it magnified the top of the graph and magnified that difference between the bars. So that's one common error. And unfortunately, this type of error happens a lot in media. Like, for example, here we have one graph that appeared on Fox News and talks about Obamacare enrollment. And I think because, March 27 versus March 31st goal. And if you look at the numbers, the goal was 7,066,000, and um, the actual enrollment was 6 million. So again, the difference is not as huge as they're trying to show here. Here's another graph that talks about unemployment rate under President Obama. So again, it looks like there was a lot of fluctuation. It went down and then it went up and then kind of went down. But if you look at the numbers again, it basically they cut off the bottom portion of the graph, and the unemployment rate fluctuates between so the lowest it was 8.8%, and the highest it was 9.2%. So that's basically 0.4% difference. And if you look from January at 9% to November at 8.6%, that's again 0.4 of a percent. So less than half of a percent. Okay. And again, these are real graphs that appeared in the media. All right. Another trick is to use misleading proportions. So basically, when graphs are made two-dimensional, so like or even three-dimensional, that changes the way we see objects. Okay, so for example, here we have daily oil consumption in millions of barrels. So this graph on the left and the graph on the right, they represent the same thing. On the left, the width of the bar is the same. And for Japan, it goes to 5.4 millions of barrels. And for US, it's 20 millions of barrels. So about 4 times as much as Japan's consumption. Now, in the graph on the right, the we they made it look like a barrel, and what happened is they instantly made this barrel wider as well as taller and thicker. So when we now look at these two of these barrels, I think the one on the left is not just 4 times as big as the one on the right, but many times bigger, at least 8 times as big. Okay, so same thing here. Um, so it says the data shows it says from this example is from the Los Angeles Times, August 5th, 1979. It says the data show a reduction in the ratio from 27% to 12%, right? From 27% to 12%, I guess, in doctors devoted solely to family practice. But so the reduction is only what, about 15%? So maybe here should be a little bit less than half than this big figure. But if you actually look at it, our perception tells that this figure is more than twice as big as this one. Right? And that is because we look at the area, not just at the height of the doctor, but also at the width. So we perceive area rather than just the heights. Okay, here's another example. How much more expensive are basketball tickets? So, and here in this pictogram, we see a representation of how much it costs to attend a game. So, basketball is obviously the most expensive ticket um, at $38, but what about hockey or baseball? Which one is more expensive? Well, it turns out that they're both the same, about $17 per ticket. But look at how the puck uh, is like looks way bigger than the baseball, even though the height is the same, but the space that it takes, the volume, the perceived volume is so much bigger. So it's very misleading. Okay, another 3D pie chart. So can you tell which category is larger? The food right here or the local passenger transport right here. So which of these two is bigger? And if you said food, you're wrong because they're both 12%. Okay, another 3D graph. Which category is taller? Number 1 or number 4? And again, if you said number 4, you're wrong because they're both uh, 0.5 units tall. So they're both the same. So see how a 3D graph can be misleading, even though visually it's pleasing and it's very easy to do right now using computers, but they may be very misleading. Now, what's going on here? It looks like the economy is doomed, right? Oh, wait, this is the heat distribution of the microwave after 1 minute of heating. So the problem with this graph is that the axes are not labeled. So we see XYZ, but we don't know what it represents. So that's another problem that you may run into. Here, mistakes are also happening. So here, the question is, does the majority of voters thinks that Scotland should be independent? Because 52% said no. So does that mean that the majority thinks that Scotland should not be independent? Well, the other majority, 58%, said yes. So in this case, it's just a typo. So be aware of that, of things that happen. And even though in the previous example, it was most likely unintentional error, there are some graphs that mislead on purpose. So looking at this graph, how did the number of murders committed using firearms changed after the state of Florida enacted stand your ground law? So it happened in 2005. Here's that moment. So what happened with um, with the number of murders committed using firearms? They dropped, right? Wrong, because um, the scale is inverted. Look with how they presented this graph. So 0 is on the top and it increases going down. So the graph should be viewed actually turned around. All right. So in summary, pay attention to the axis, labels, and units. Number 2, avoid 3D. Number 3, don't be afraid to ask questions. All right, so this is it for this video, and I'll see you in the next unit.